So my project was to work on a software that does dictionary attacks for you, and specifically I was trying to port dictionary attack software known as Hatch, which is open source, to use Tor browser instead of Google Chrome. So in my first submission, this is the description that I attached with it. In my first submission, what I did was I only submitted one file in which I converted it to Python 3 from Python 2, and moreover I started using Tor instead of Google Chrome. That is all I did. And for now for our last submission, so let's summarize what work we have done. We ported the program to Python 3 and used Tor instead of Chrome for some degree of privacy. And for our second submission, I wrote special functions to carry out the attack on XC College student portal that is Empower. Also there was another big change that I did. So in the first submission, if you run this one program, what it did was that it opens the Tor browser. So here is a demo of how to use it. You enter the website. It checks if the site exists. Then you enter the username selector. And this is how you select it. You click inspect. You click the element. You right click the element and copy selector. You copy the selector. You paste it. Now it asks for the password selector. We do the same thing with the password field, and then it asks for the login button selector, which is to do that, and then it asks you for the username to brute force. So you for example, you enter my username, and then it asks for the file which contains the password. So let's use this file that I have also attached the first submission. And then what it did was that it opens the Tor browser. And let's see how it conducts the attack. Now it will enter my username and a password from that password dictionary, and then we will click the submit button and see if we successfully logged in. Since we didn't, it will check the other password and so on. So the problem with this was that we don't really want to see the browser opening up and conducting the attack. So I instead used a headless Tor browser. What that means is that now you won't see a tall browser window opening up. Instead, it will do everything in the background. Okay, so I ran that program for a little while. Then I noticed that each roll number took on average 8 seconds. To check a roll number against a password and to see if you successfully logged in or not, this whole process took 8 seconds. So if I want to, so remember that in my proposal I proposed that I would conduct a dictionary attack where I will check uh, all the usernames of FC students against some passwords. So by default, every student has the same username and password, which is their roll number. So I would, using this program, I would see how many students have actually changed their passwords, or if it is still their roll number. So for example, I observe let's say 1500 students enroll in every batch. So if I want to check the roll numbers of 1500 students, it would take me 12,000 seconds or or 200 minutes or almost three and a half hours. So this will take a lot of time. So another thing that I did was to use multiple threading. Now what happens is that multiple Tor browsers open in the background and they check for the username, the roll numbers against their passwords. So we went from a very simple program that was developed by someone else and was made open source, and we added these functionalities. Multi-threading made it headless and made a special function to attack the student portal. So this was the first submission. It has these are some configurations, these are some imports, these are some configuration, the command line arguments. Then there is this wizard function which you see when you run the program. It asks for the username and the website and the different username selectors which I just showed you. And then there is this main function brutes, which checks usernames against passwords, and this is some cosmetic stuff. And then this is where the brutes is actually called. So this was the original. This is what I submitted in my first submission, and now the this is the final product. Here I have again the same stuff, and then I updated the wizard a little. This is the same function, I didn't change it a lot. And then this is self brute, where the self here means that it checks the same string as username and password. And then these are some functions that run different jobs in parallel. So split, what does the split function do? What I do is it takes this and I'll show you just in a moment that when you run this program, it asks for the list of roll numbers that you want to check, and if the parallel option is if the parallel flag is given, it divides the usernames into into the number of jobs that you want to run in parallel. So if, for example, if the value of jobs in parallel is 3, it splits the usernames into 3 parts, and each job can check those usernames independently in parallel. So that this greatly improves the speed of this program. So let's now go towards a demo. So I'll show you the whole process of how you can check roll numbers. So for example, let's first I'll generate a list of all the roll numbers. So let's check the roll numbers of 18 series students. So I've noticed from my experiments that the roll numbers start with 18-1, and next I'll generate a list of all the roll numbers using by appending pre to each roll number. The roll numbers will range from 0 to 1500, and let's check the first 10 roll numbers. It starts like this: 18-1, 18-10,000, 18-10,000, and then 18-10,009. And for the last, let's check the last 10, and it goes up to 18-11,500. So let's write this all in a file. I've written all the roll numbers in a file, which I will then give to the. So here, instead of writing in each and everything in the wizard, another thing that you can do is give all the required parameters using using command line arguments. So here I run Python TorHatch, which is our program, and then you can give the username selector, which is this, and the password selector. Here is the login selector, and then the website, and I have given the self check flag, which means to check the same string as the username and password. Then I have given the parallel flag, which tells it to run the processes in parallel. And then for to give it I have to give it the list which contains all the roll numbers. So I've named that list. What was the name? I guess it was 18 series.txt. So I have to run this. Oh, but first there is something that I have not let's convert this into 18. Okay, I'm still working on it. Okay, now we can run it. So now it's starting up all the 3 Tor browsers in parallel. the only drawback is that in the beginning it forms the torch circuit, which is your and now it's running. So remember that our roll numbers ranged from 10,000 up to 10,000 11,500. So it divided the roll numbers in three parts. So the three parts are: the first part starts from 10,000, the second part starts from 10,500, and the third part should start from 10,000. There it is. It took a while. The third part starts from 11,000. So remember that I told you that the first submission, which did not have parallel processing, took 8 seconds on average for each roll number. So let's time it, how much roll number takes here. So it's less than, you can even observe it that the rate at which we are checking a roll number is way less than 8 seconds. So we have yet not seen a hit. Oh, there it is. We have just found a hit. So numbers that the roll numbers that have the same username and password are then written in this file, sabotage users 18. So here the roll number is written. So let's check if this roll number actually has the same username and password. So there we go. This is a person from 18Cs who did not change his username. We can check his data. There is his phone number, father name, age, and email. So this is a very dangerous thing. SC should change their policy regarding what they place as their default username and password. So I think that is all. While it is running in the background, let me just walk you through the code. I think I've already walked you through the code. Let's discuss what future changes can be made in this work. So I'll probably make it open source, and what I really want to do with this project in future is to convert it into to make an object-oriented API. So instead of these big chunky functions, I want to make a class with methods in such a way that other people can also use the nice features which TorHatch gives you. They can simply, for example, create an instance like this, . and they can set their um, initial instance variables. So something like that, and then they can further they can add their own code, user code over here, whatever they want to do with the results of running this attack. So this is what I want to do, make an object oriented API in the future. I think that is all for this project. Thank you.